Hi, everybody. This is section 6.1. It's called normal distribution. We've had parts of this already in the course. See this formula right here? Don't look at it. We're not going to use that. We're going to use our calculator. So we're going to skip all this. I'm gonna skip this part. There's a good portion that we're gonna skip here. We're gonna start off right here, 6.1 right here. So we're looking at normal distribution. Remember we did Chevyshevs and the normal distribution already. So we're just doing a little bit more with normal distribution. Normal distribution is a bell-shaped curve. It's called a bell-shaped curve. This center is where the mean, median, and mode all are the same number. Mean, median, and mode at the center of a normal distribution curve are all the same. If you look at this, it's called normal distribution. It's symmetrical. Half of it is on the right side, and half of it is on the left side. So it's symmetrical, the same shapes on both sides if you break it down in the middle. The middle is, once again, the middle is the mean, median, and mode right there in the center. What else do we need to know? Let's scroll down a little bit. We're going to take a look at the normal curve here. The normal curve, this normal curve, once again, if you added it all up, if you add up, by the way, if you add up this, that's 50%, right? That's 50% of the curve. Half of it to the left, and another half of it, 50%, is to the right. Okay, that's okay. And then we're using, once again, the mean. We're calling the mean at the center. If we move one standard deviation, do you see this is the mean plus one standard deviation? I hope you can see that. And this is the mean minus one standard deviation. So if I take one standard deviation and subtract it from the mean, one standard deviation, and add it to the mean, then this is the amount of the normal curve that we're talking about, that's shaded in. One standard deviation to the left and one standard deviation to the right. We have to understand one standard deviation on both sides of the mean make up 68% of the entire bell-shaped curve. Do you see? That's 68%, one standard deviation. And you have to know these. But by the way, they're right here. You have to know these because these are, when they're saying using the normal curve, how much of the curve is one standard deviation away from the mean? Well, one standard deviation to the right, one standard deviation to the left, it all adds up to 68%. So if one standard deviation to the left and right add up to 68%, what about just this area right here? How much does this add up to? What percentage is this shaded in? Anybody know? It's 34% because one standard deviation that way and one standard deviation that way, 34% and 34% add up to 68%. Do you see? The whole thing is 68%. It's symmetrical, so half of that is, half of 68 is 34%, and 34% on the other side. It adds up to 68%. All right. Next, 2 standard deviations from the curve. Here's the from the mean. If we go 2 standard deviations to the left and 2 standard deviations to the right, the mean minus 2 standard deviations, and here is the mean plus 2 standard deviations. And if we look at all of that, that's underneath the curve, all of this is 2 standard deviations. 2 standard deviations is 95% of the curve shaded in. So it's always going to be, when they say the normal rule, what percent is shaded, 2 standard deviations, it's 95%. By the way, it's a little bit more, 95.12 or something like that, but we round it, when we look at this, we round it, we just say, oh, it's 95%. I mean, this is the only thing when we're saying approximately. That's why they say approximately. We're going to go to exact later on in this section. And then finally, 3 standard deviations. 3 standard deviations is this much. Look, it stops right there. 3 standard deviations and 3 standard deviations. So all of this is shaded in. The only part that's not shaded in is this little part here and that little part there. 3 standard deviations is 99.7%. That's pretty much all of it, right? It's almost 100%. 99.7% is 3 standard deviations. So you have to remember those 3 or have those 3 written down, and we have them written down right up here, because you definitely will see that again. All right, so that's the basic normal curve. And we're going to have our calculator do a lot of this, by the way. And once again, the standard normal distribution is normally distributed with the mean of 0. So we call this, by the way, these are our z values down here. Z values. I wish I could have it a little bit bigger. These numbers are our z values. Does it even say? A z value equals 0 right there. That's our mean when z is 0. 1 standard deviation is a z value of 1. So 1 standard deviation is called a z value of 1. 2 standard deviations is a z value of 2. And of course, 3 standard deviations away from the mean is a z value of 3. If we go to the left, we call this a z value of -1. So the left of the mean, because we have 0 to the right, we have positive z values. To the left, we have negative z values. Z equals -2. And here, z equals -3. Z values are standard deviations. Once again, 1 standard deviation away from the mean, 2 standard deviations, and 3 standard deviations. We could say this z value equals 1, this z value equals 2, and this z value equals 3. And once again, the z value at the mean, since it's not anything, I mean, that's the mean, we called it a z value of 0. You're 0 away from the mean. Z values is how far away, or standard deviations is how far away from the mean you are. All right, so we're going to be dealing with a lot of z values today. I can't express enough to make sure you go back and watch that 5.2 video that I did. And they're just showing you again, a z-value of 0 is the mean. That's our mean. And then here's the z-value of 1, z-value of 2, 3, -1, -2, -3. You don't have to always have z-values. You can actually have the actual mean. Mean is 10, 10. And then if you go, this is one standard deviation. If the mean is 10, 10 and one standard deviation is 10, 30, 10, 30 minus 10, 10, that means one standard deviation is 20 away from the mean. You see, one standard deviation is 20. You could say one standard deviation is 20. Two standard deviations would be 40 then. Do you see 40 more than 110? If you add 40 to it, you get 150. If you add 60 to 10, you get 3 standard deviations. So you could use z-values or you could use actual numbers from your data. Normally, when we do this on our calculator, we usually always use our z-values. There's other ways of doing this, but we're going to try to stay with finding the z-values and using the z-values when we plug this into our calculator. Anybody has any questions, just yell it out. Okay, so don't forget our formula. This is our z-value formula. Z, once again, z is how far away from the mean we are. X is the value. Here is the mean, the average. And standard deviation is that symbol. So we're going to use z equals x minus the average divided by the standard deviation. By the way, this is population. If we did sample, it would look like this: x minus x bar divided by s, right? This is the mean for a sample. This is the a sample standard deviation. This is population mean, and this is population standard deviation. So the formula is the same. You're just using different symbols depending on if you're talking about a population or talking about a sample. So let's remember this formula. All right, so for this problem, I'm going to draw a normal curve. We know this is the mean. The center is the mean. The average teacher salary is 54156. That's the mean. Average is the mean. So I'm going to put 54156. That's the average. If the standard deviation is 10,400, find the salary for a z of 2. Here's a z of 1. Here's a z of 2. In other words, we have to add one standard deviation and then add one standard deviation, and we want to find the salary. Well, one standard deviation is 10,400. So here's the mean. Add one standard deviation and then add another standard deviation. It says, because we're looking for 2 standard deviations, a z of 2. So when I put that in my calculator, 54156 plus 10,400 plus 10,400, I get a z of 74. I get a salary of 74,956. Okay, so if my mean salary, if the middle salary is 54,000, and then I said find the salary for a z of 2, I have to add 2 standard deviations. Well, one standard deviation is 10,400, so you have to add that twice. And this is the z of 2, 74,956. Now, what about a negative 2? 54,156. We want to find negative 2. So we subtract 10,400, subtract 10,400. So I'm for this middle one, I'm going to start with 54,156 and subtract 10,400, subtract 10,400, and see what I get. 54,156 minus 10,400 minus 10,400. And this teacher only makes 33,356. Yeah, I'd rather be this teacher than this teacher. So the average teacher makes 54,000. Some teachers make more than that, 74,000. Some teachers make less than that. So here's a question for you. If 2 standard deviations is 74,000, a minus 2 standard deviations is $33,000. What's a z of 0 equal? How much does that teacher making at z of 0?
54,156.
Yeah, that's the mean. A z of 0 is the average, 54,156. So we just answered all 3 of these without using a calculator other than add it and subtract it. So that's pretty cool. Thanks for the answer. All right. Everybody okay so far? Moving on. Well, eventually we're going to get to the real calculator stuff. I think the calculator stuff is really easy, hopefully. We'll see. Maybe not always. All right. So, we want to find how much of the area of this. By the way, there's about 4 or 5 questions on the test that look like these problems, or the ones we're going to be doing today. So on test 3 that you're going to be taking in 2 weeks, there are about 4 or 5 questions with these on there. You have to know how to use this calculator, and you have to understand, a z of 0 is right here. And these are positive z's are always to the right, negative z's are always to the left. Okay, so we need to know that. And we want to know what area is shaded in here. We want to know how much, what percent. Can somebody give me a rough percent of what is shaded in? Just look at it. I mean, I don't know what the percentage is because it doesn't tell me, but about what percent is shaded in?
80%.
Yeah, 80% sounds good, 80% of it is shaded. That means 20% is not shaded. It has to add up to 100%. Here we could say 20% is shaded and 80% is not shaded. We could do the same thing. So that's what we're going to be doing on our calculator. We're going to find the exact percentage, but we're going to use a decimal equivalent to find out how much is shaded in. Now, luckily, we're using our calculator because this is similar. I mean, there is a binomial distribution table, and I think I have it in next week's module. We're not going to use that. I put it in that module because some students wanted to use it because the homework says use the following normal distribution table. Do not use the normal distribution table. Use your calculator. So our calculator, and just like binomial distribution, our calculator will only go to the, the table will only show you what's shaded into the left, not what's shaded into the right. If you remember the binomial distribution that we did. But our calculator, the way we're going to do it, you can go, it's going to be really easy. It's going to be easy. I do want you to know if this is a z, let's call this a z of -1. Can somebody, it's shaded in way over here. What do we call that z? We know there's a z of 1, maybe a z of 2, maybe a z of 3. What's way over here? Keep on going to the right. What number is way 3, 4, 5? What number is way to the right? Infinity, correct? It actually goes on to infinity, really small to infinity, goes on to infinity. But we're not going to use infinity on our calculators. By the way, we have to actually type in infinity. We're not going to use infinity. So everybody, infinity equals 99. 99 standard deviations is infinity. By the way, 9 standard deviations is infinity. Remember, we did 3 standard deviations. That was 99.7%. That was 99.7% of our data. So 9 standard deviations is pretty much 100%. I'm calling infinity 99, a z value of 99. So I'm saying infinity, we're just going to use 99 when we get to it. All right. I know this doesn't make sense yet until we do an example. And I'm still going to keep on going. Here's that table. We are not going to use it. By the way, no, we're not going to use it. Oh, well, let me look at the table and show you. Remember we said a z of 0, a z of, by the way, z's are always 2 decimal places. A z of 0.0, and then this is 1 more decimal place, 0. Remember, a z of 0 is in the center, and if you look at it, that's 50%. 50% shaded in. So I just wanted to show you the table, but we're not using the table. All right, so here's a question very similar. These 4 or 5 questions like this that are on the test, okay? It says, find the area under the curve. What portion is shaded in under the curve? We have a z of 2.09. This is the right part of the shaded area. What do we put down for the left part? The far, we have to look at the shaded area. We have to indicate the z value for the far right, and we have to indicate the z value for the far left. What z value do I put for the far left? Anybody know?
99?
Close. 99 is over here. Negative 99 is on the negative side. Do you see? So we're typing in, it's infinity, negative infinity, but we're going to type in a z value of 99. So I'm going to do this on our calculator. And we're going to figure this out. Let me type it in first. It's second vars. Yes, so I'm going to show you how to do it. I'm going to type it in first. We're going to type in second calculator, second vars, and second vars, and then we got to go to number 2. We're only going to use number 2. We will never use number 1. It says normal CDF. The PDF is equals, and we're not looking for equals of number. We only use second vars number 2 for the normal distribution curve. And then I hit enter, and then it asks me the lower. Then it asks me the upper. and then it says the mean and the standard deviation, and I'm going to change these colors. Mean always has to be 0. Standard deviation always has to be 1. So we just have to fill in these two parts. The lower is the left side. Uh-oh, hang on. The lower is the left side of our graph. The upper is the right side. So on the lower side, we're going to type in 99. On the upper side, we're typing in 2.09. You see, we're typing in those z values. So on my calculator, I'm going to hit stop share for a second. Should probably mess this all up. So on my calculator, I'm going to hit second, vars, and then we're going to go to number 2. Hit enter. Our lower, we said, was going to be negative, not subtract 99, negative 99. Let's see if I can focus out a little bit better. I don't know. It's okay. And the upper was positive. The right side was positive 2.09. Our mean should always be 0. Our standard deviation should always be 1. And when we hit enter and then hit enter one more time, it tells us what portion of our graph is shaded in. So the portion that's shaded in, and by the way, the percent shaded in, use decimal numbers, not percent. And you always round it to 4 decimal places. So the percent shaded in always goes to 4 decimal places. And on my calculator, I get 0.98169. That's 5 decimal places. I round it to 0.9817 because this is 5 or more. So this is the answer. This there 98% is shaded in, 0.9817. That's not bad. That sounds pretty easy. All we have to do is type it in our calculator. Everybody okay with that? Second vars, number 2. The left side you put in the lower, the right side of the graph, you put the z value in the upper. The z value in the lower we said was negative 99, which is the same as infinity. And then we're good to go. 0.9817. That's and if we, I'm going to now scroll down. If you look at this, I'm not going to do any more tables. I'm going to do one more though. Let's look at this table right now. Do you see from the left of 2.09, see here's the 9, 2.09, I don't think, oh, it's right there. And that's what we got on our calculator. 2.09 from the table, that's what we got. That's the last time I'm going to use the table. When your homework says use the table, just use your calculator, unless you want to use the table. Everybody okay with that? Everybody all right? Let's see. We got more of these we're going to do. All right, let's find these areas, the area under the curve. So when we go to second vars, what am I going to type into my lower? What am I going to type into my upper?
Be negative 1.14, and then the upper will be 99.
Exactly. This is infinity. We use 99. When it goes on forever, we're going to use 99 standard deviations. Here, the lower, the left side, remember, lower is the left side of the graph that's shaded. The upper is the right side that's shaded. It goes all the way to the right. So let's put this in our calculator and see what the z value is, or see what percentage is shaded in. And I'm going to stretch this out. And so I'm going to go to second vars, number 2. My lower is going to be negative 1.14. Don't hit subtract. I think it gives you an error. You have to hit the negative. And my upper is going to be a positive 99. When I hit enter, 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 and enter one more time, it finally tells me my answer. 0.8729 if I round it to 4 decimal places. So it gives me 0.87285. Look to the right, 5 or more, 0.8729. So 87% is shaded in. All right, so we're going to try the next one. The lower, the only thing we need to do, second vars, lower and upper. The lower is on the left side, negative 1.35. The upper, it stops here at a positive 1.62. I'm going to do the second vars and put that into my calculator. Second vars, number 2. Lower, we said, was negative 1.35, negative 1.35. The upper was a positive 1.62. And when I hit enter, 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 and enter one more time, it tells me somewhere around 85% is shaded in. 85.887. 0.88, that's not right, 0.85, 0.85887, but you when you round it to 4 decimal places, you always have to take it to 5. 5 or more, you add 1, so I get 0.8589 as my answer. 85%, a little bit more than 85% is shaded in. That's pretty easy. You just use your calculator. But you got to practice it. I promise you, so many people mess these up because they don't practice it. You have to actually grab your calculator and practice those. For those of you that are sleeping right now or watching TV while I'm talking. It's okay. Let's try a couple more. We have how many of these where we got? We got, look at all these. We got about 5 or 6 more to practice. All right, good. Well, let's try this one. I just want to know what my lower is going to be, the left side, and my upper. What's my lower going to be for this one?
Will be 0.
Yeah, it's the same number that's there. It's going to be 0, and my upper is going to be 2.53. Second vars, number 2, lower is 0, upper is 2.53, and my answer for this one is 0.4943, rounded to 4 decimal places. All right. So next one. I hope people, is everybody following along?
Yep.
Well, you said yeah, but I'm hoping everybody is.
Yes, we're here.
Okay, good. So the next one, our lower and our upper. I know if I was doing this online stuff, I might be watching TV or playing Xbox. I don't know. I'd probably fail the class though. My lower for this one. Okay, somebody who hasn't said anything yet for lower or upper, because I think only one person has been answering. What number do I put for lower?
0.
For this one, it's not 0. What's the
Negative 99.
Yes, do you see way over here, the far left that's shaded in? 0 is marked. They're just showing you that this is the middle. But the far left that's shaded in is negative 99.
Oh, okay.
Okay? And then the far right that's shaded in is, I wrote on it, so I can't tell.
1.73, I would imagine.
1.73, yes. 1.73. All right, so let's put those in our calculator. Second vars, number 2. We always use number 2. Don't use number 1. You'll get the wrong answer. Second vars, normal distribution, number 2. I'm putting negative 99 and 1.7. Did I say 2 or 3?
3.
1.73. Okay, that's what I wrote down. It looked like a 2 to me. And I hit enter, 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 enter. You got to hit enter a lot. And it's like 95%, 0.9582 if I round it to 4 decimal places, because the 5th number is more than 5. All right, let's try this one. The lower and the upper. And we're doing this many because there are this many on the test. I'm telling you, that on test 3, there'll be about 5 or 6 of these on the test. So if we get the practice now, we got it down. So the lower is the far left, 1.98. And the upper is the far right, a positive 99. Infinity, which is a positive 99. Second vars, number 2, 1.98. And upper should be 99. Enter, enter, enter. And it says a small percentage is shaded and only about 2%. I get 0.239. 0.0239. 4 decimal places. All right. That's pretty good. I have one for us now. I'm going to shade in a little bit more. Don't look at this. Can somebody, this is all shaded in here. Can somebody tell me what portion is shaded in? What's my answer? You should be able to.
50%.
50%.
Yeah, the answer is 0.500. Let's try it. For your lower, the left side is 0. Put 0 in. For your upper, put 99. When you do that in your calculator, you should get 0.5000. Just to show you that's 50%. Second vars, number 2, 0, and then 99. And mine says 0.4999999, right? Does yours also?
Yeah.
Yeah, but if you round it to 4 decimal places, it rounds everything to 0.50. Let's see what else we have. Oh, now we have to find the z value. Uh-oh. I thought we were done for the day. So we have 3 more problems apparently. And this is a new calculation on a new calculator button pushing. So the previous problem found the area under the curve. The previous problems we did found the area under the curve. Here we want to find the z value. We want to find z. Z equals. And by the way, when we do this on the calculator, your calculator, on calculator, it will only work for shaded to the left. Just show you. Do you see the if I want to find the z value, it tells me to shade it to the left. See this z value here? Shaded to the right. Our calculator won't tell me this, but there's a way of doing it. Okay? So it will, our calculator will tell me the z value when I type in this area. It will tell me the z value only if the shading is to the left, like it is here. Okay? So our calculators, let me verify this, second vars, number 3. So to find the z value, to find z from shading, shaded left, second vars, number 3, inverse normal. So go to, if you're following, hit second vars number 3, and it's going to say area. It's going to say average is 0, standard deviation is 1. Leave these as 0 and 1, like I said before. And we're going to find the z value here. By the way, can somebody tell me something special about the z value? Just tell me what you know about that z value right now. The obvious.
3 away, or 3 standard deviations.
Well, it's not, it's negative. What I wanted, do you see it's on the left side is 0. So when I put this in my calculator, I better get a negative answer because the z value is on the left side is 0. This z value better be negative. So on my calculator, when I do second vars, the area is 0.0188, 0.0188. So I'm typing that area, 0.0188, hit enter, 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 enter one more time, and it gives you the z value. The z value at this point is z equals negative 2.079. Z values are always 2 decimal places. The area under the curve are 4 decimal places. Z value is always 2 decimal places. So this z value is negative 2.08. So that's what that Z value is, negative 2.08. All right. So now we got to do the next one. Oh no. Let me just clear the whole page. I have to find the Z value. But when I find the Z, if I type this into the calculator, it's not going to give me the Z value. It's going to give me, by the way, what should the Z value be, positive or negative?
Negative.
Yes. So somebody just type in this number into the calculator. Second vars number 3. Let's type that in. Let's just see what we get. We're not going to get a negative answer, but let's just see. Second vars number 3. And I'm going to type in 0.8962, 0.8962. Hit enter, enter, enter. And do you see how I get a positive answer? So I know that answer is wrong. I get 1.26. I know that answer is wrong because I should have a negative. Because our graph will only give us a Z value here if we know what portion is shaded in over here. Can somebody tell me what is the decimal equivalent that's shaded in on this side?
0.20 or 0.11.
You're close. Yes, it's 1 minus 0.8962. Do you see this side and this side have to add up to 1? They both have to add up to 1. So we take the 0.8962, subtract it from 1. 1 minus 0.8962. So this is the number I'm going to type into my calculator. 0.10. You have your microphone. Your conversation. So type in 1038. Second vars. Number 3. Is somebody eating their microphone? 0.1038. 0.1038. And when I hit enter, 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 it gives me a negative number. And remember, Z values are 2 decimal places. So this Z value is negative 1.26. By the way, because this is symmetrical, remember we typed in this number and we got a positive 1.26. Because it's, if we did, it would actually tell us this number, 1.26, because it's still 80% or whatever here, and then the rest is here. It gives us the opposite sign. I just wanted to, some people will figure that out later on when they do this. But I mean, this is, your calculator will only tell you the Z value if you know the percentage shaded into the left. All right, let's try another one. Uh-oh. This is a tough one. We have to find this Z value. The only way to find this Z value is to know the area to the left of it. How do I find the area to the left? How do I find this area? What is the decimal equivalent to this area right here?
1 minus 0.4175.
You're close. It's not 1 minus because the whole thing is not shaded in. It's not 1 minus.
0.5.
Yes. Do you see? It's half of this minus this. So it's 0.5 minus 0.4175. And I'm going to put, because only half of it is shaded, it stops at 0. See, the other one, the whole thing was shaded in, so we said 1 minus. But here, half of it, so 0.5 minus 0.4175. So the shaded part, the part that we're looking for is 0.0825. This is what we're going to put into the calculator. 0.5 minus 0.4175, which is 0.0825. In calculator, second vars, number 3, and I'm going to put in 0.0825. Second vars, number 3, and 0.0825. And my z value, this z value that we're looking for is negative z equals negative 1.39. Z values always go to 2 decimal places. 0.388 rounds to 0.39. And make sure that, you know, it's on the left side of 0, so the z is negative, so you're just going to verify that. All right, any questions from anyone? Any questions?
Yes, I have a question.
Yes.
Is it possible that the z could be on the positive side?
The z could be on the positive side, but not the ones we just did. I mean,
Yes.
the one we, right. Yes. Let me, how about, wait. Here's a normal curve. Like where, here's the z of 0. Do you, what are you talking about? Trying to find this z value?
Yes, I was asking if there will be an instance where z will be on the right side.
Yeah, we had examples where the z is on the for that particular problem. No, the shaded in is always going to be to the left on our calculator. For second vars number 3, the shaded part always has to be to the left to find that z value. It always has to be to the left. But let me go back to the homework. Let me go back to the book if I can do that. But we had z value. I don't think I understand the question. But we had z values on the right-hand side. It just none of them were here. Yeah, you're right. See, we had z values up here on the right-hand side. But you're right. These are all like this. I mean, here's an example. I can do a quick example, I think. Find this z value. There's 0. If this part shaded in is 0.7777. Do you see? Find this z value if all this is 0.777. So you just put this in your calculator. Second vars number 3. 0.7777. And you see our z-value is positive. We have a z-value of 0.76. Z-values always go to 2 decimal places. I hope that answered your question, did it?
Yes, it did.
Okay.
Thank you.
Mhm. Any other questions? All right, wait, don't leave. Let me finish taking roll. Lauren is here. Manveer is here. Alan is here. Alan is here. Alan, yes. Eric, yes. And the only person I'm missing then is Zachary. Zachary's here. All right, everybody's here. You guys have a good weekend. What? Yes, weekend. I'll see you on Monday. Don't forget, watch that video again on section 5.2 at the end. That's that problem I missed. And I want you to rewatch it because I fixed it.